Welcome. Once again we will learn if n belongs to natural number, then we must need to prove that 3 to the power 4n plus 2 plus 5 to the power twice n plus 1 is divisible by 7. To prove that this is divisible by 14. Divisible by 14. So with using mathematical induction for first few natural number, the statement we must need to prove that it is divisible by 14. And the k and k plus 1 also is divisible by 7. Let the statement as n 3 to the power 4n plus 2 plus 5 to the power twice n plus 1. If S1 equal 3 to the power 4 into 1 plus 2 plus 5 to the power 2 into 1 plus 1. This is 3 to the power 4 1 the 4 plus 2 as 3 to the power 6 plus 5 to the power 3. 3 to the power 6, that is 3 cube into 3 cube, or 27 into 27, which is 729 plus 5 cube, or this is 125. Here 4 1 5, then the 854 also divisible by 14, because 84 which is divides 6 again 161 times. This is which is divisible by 14, which is divisible by 14. Let us try out putting 2 in place of n. We must take as 2, then 3 to the power 4 into 2 plus 2 plus 5 to the power 2 into 2 plus 1. This is here 3 to the power 8 plus 2 as 10. 3 to the power 10 plus here 5 to the power 5. 3 to the power 10, 3 to the power 10, which is 3 to the power 5 into 3 to the power 5. 3 to the power 5 is 343 into 343. So 3 to the power 10, which is 3 to the power 5 into 3 to the power 5, that is 3 to the power 5 as 243 and another 3 to the power 5 243. The product is 57,049. 57,049 plus 5 to the power 5, which is 3,125. Sum of the values 4 7 1 0 6. So 3 to the power 10 plus 5 to the power 5. 3 to the power 10, which is equal here 3 to the power 5 into 3 to the power 5. That is 243 into 243. We have the value 59,049. 59,049 and 5 to the power 5, 3,125. Now let us sum up these values. 4 6 1 7 1 3, 9, 12, 2 in hand 1, 5, 1, 6. 62,174. This value, 62,147 is completely divisible by 14 into 4,441. 14 into 4,441, we will get this value. This means this value also divisible by 14. So therefore, let us take k also divisible by 4. Value of k also is, let sk will be divisible, sk will be divisible by 14 for n equal k. For the value of 1 also is divisible in place of n, 2 also is divisible, then for the value k also is divisible. Let us prove the statement is divisible for next of the k, that is k plus 1. Now as k plus 1, in place of n we will put k plus 1. Then the statement 3 to the power 4 k plus 1 plus 2 plus 5 to the power 2 into k plus 1 plus 1. So wherever the n we have to put k plus 1, and this statement also is divisible by 14. Now 3 to the power 4k plus 2 plus 4 into 1 as 4 plus 5 to the power twice k plus this 1 plus 5, this is plus 2, which is here 3 to the power 4k plus 2 into 3 to the power 4 plus 5 to the power twice k plus 1 into 5 square. Now this can be converted as 81 into 3 to the power 4k plus 2 plus 25 into 5 to the power twice k plus 1. This whole part we can express as the 81 is not divisible by 14. The next of 81, which is 84. So we can write as 84 minus 3 is equal to 81 into 3 to the power 4k plus 2 plus this 25 also is not divisible. So we can write it 28 minus 3 into 5 to the power twice k plus 1. Then we have here 84 into 3 to the power 4k plus 1, 4k plus 2 minus 3 to the power 4k plus 2. 3 into 3 to the power 4k plus 2. The next is 28 into 5 to the power twice k plus 1 minus 3 into 5 to the power twice k plus 1. Now this is already divisible and this also already divisible. So we will arrange one side. Let us arrange this divisible part 84 into 3 to the power 4k plus 2 plus 28 into 5 to the power k plus 1. The remaining here minus 3 we can take as common. Minus 3 we can take common here, so that we will get here 3 to the power 4k plus 2. The minus we will get the plus, then 5 to the power twice k plus 1. As we know, this part is divisible, this is also divisible, and this is also divisible, because we have taken that for the value of k, this portion also is divisible by 14. Therefore, this is which is divisible by 14. Thus, for any natural number n, the whole statement, that is 3 to the power 4n plus 2 plus 5 to the power twice n plus 1 is divisible by 14.